Hello. Good evening.
Good evening, sir.
Okay. Yeah. So, as I told you in my last class, that I will take a small Viva on Monday. So, all of you prepared for the Viva? I will ask few questions related to my previous lectures. So, okay. Have you revised your topics that I given to you?
Yes, sir.
I told you that revise electric field and electric forces. Okay. So I will ask a few questions so that I can get the idea that you are properly revising your syllabus or not. Okay. So Minashi, I will ask few questions to you. Okay.
Yes, sir.
Okay. So tell me, if I put two charges, suppose I take a charge Q, E, Q1, which is equal to E, and another charge, which is Q2, is equals to 2E. And these two charges are in vacuum. So what will be the force? What will be the expression of force?
1/4 pi epsilon Q1 Q2 by R square.
Q1 Q2 by R square means I have given the value of Q1, which is E, and Q2 is equals to
E
2E.
into
So
2 by R square.
means it's 1/4 pi epsilon naught 2E square by, if separation distance is R, then R square. Okay. So my next question, what is the relation between electric field and electric force? Minashi, I'm asking you. What is the relation between electric field and electric force?
E equal to F by Q.
E equal to F on Q. Okay. Where Q, is there any limitation on Q?
Yes, Q is equal to 0.
Q tends to 0, not equal to 0.
Tends to 0.
Okay. Q tends to your 0. Okay. One more question, last question to you. What is electrostatic force constant?
K.
K, capital K, and what its
K.
value? What its
9.
numerical
9
value?
into 10 raised to 9.
10 raised to the power 9.
9.
Okay. And what's the unit of this K?
Unit meter.
Newton.
Newton M minus 1 C.
No, unit. I'm not asking dimension. Newton, then?
Meter.
Meter square.
Coulomb.
And one more thing, per coulomb square.
Yes.
Okay. The value of K is important because you have to remember the value of K, because most of the numerical, when the value is not given, so you must have to remember the value 9 into 10 raised to the power 9. Okay.
Yes.
So next one is Maziha. Are you listening me, Maziha?
Yes, sir.
So I will ask few questions to you. Okay. So my first question is, what is this symbol? I am writing a symbol on my screen. What is this symbol?
Sorry.
Epsilon naught. Epsilon
Epsilon.
Okay. And what it tells?
Sorry.
What it tells? Epsilon naught is the name of the symbol, but what it represent in electrostatics?
Free space.
Free
Electric
space.
constant.
Free space, but what free space? there is one more thing you have to tell. What is free space? But what free space?
It is the permittivity.
Exactly, it's the permittivity of free space. Okay, one more thing. And if I remove this not term, if I write only epsilon, then what it tells?
Free space.
Huh? Is what is it? It's a epsilon, or it is a permittivity of free space. But what this epsilon, if I remove this not, then what this epsilon? Hmm? Okay, you haven't, I think, revised your notes. This we called absolute permittivity. This we called absolute permittivity. One more question. What is the relation? What is dielectric constant? What is dielectric constant?
It is the the E is equal to no.
Yeah, we dielectric constant or relative permittivity. These are the same thing.
ER is equal to EM by E. No?
Okay. So I think you haven't properly revised your notes. I think one more question. One more question. If I put a charge, capital Q, okay, and it's a point charge. If I put a capital Q, a point charge, okay, and if I want to calculate the electric field at this point, which is somewhere r distance from here, okay, so that I bring a small test charge Q here. So what will be the electric field due to a point charge? This point charge is capital Q. Can you tell me what is the electric field due to this point charge, capital Q? Huh? Take a look of your notes. In my previous lecture, I derived this. What will be the electric field due to a point charge? Huh? Hello, Maziha, are you listening? Okay, it's okay. Okay, so there are two students here, so I asked 3 questions. I'm asking these questions because so that you can take proper division of your previous lectures, so that you will be able to understand the next topics. Okay, so today I will start from superposition principle. Superposition principle, and I already give you the statement of this superposition principle. Today I will briefly discuss this superposition principle, and I will do some numerical related to this principle. And after doing these problems, you are able to find electric field due to system of charges. Due to system of charges. Up to now, you are able to find electric field due to a point charge. Okay, so what happened when you are dealing with system of charges, means more than one charge? So in that case, the superposition principle will work, and by using this principle you can find the net electric field due to system of charges. Okay, so I'm again writing what is the principle of this superposition principle. Superposition principle says For a system having, it says, for a system having an interacting point charges so the net electric field at a point is vector sum of the electric field due to the individual charges, It's very easy. Okay, what this statement says, if you have more than one particle, more than one charge, then what you will do, you will treat it as an individual charge. You will find electric field as an individual charge, and after that you will sum up, not algebraic sum up, it's a vector sum. You will take a vector sum of all the electric field. Okay, for example, if I consider a charge q1, which is positive plus q1 charge. Okay, so and there is another charge which is q2. Okay, and you have to find, if you are calculating the net electric field, okay, net electric field due to this system of charges. Okay, suppose you want to find the net electric field at this point. Okay, so what you will do, you will find electric field due to this q1, which is outward. You will find electric field due to q2, this is again outward, and you will take a vector sum. This is your electric field E1 and this is your electric field E2, and you will take the vector sum which will go in between this. This is the net electric field. Okay, so here you can write the net electric field is equal to E1 plus E2. Okay, and what about more than two charges? More than two, more if you have 1, 2, 3, if you are n number of charges, if you are in the statement I wrote, for a system having n interacting point charges, what happened when you have n number of charges? So in that case, we take the vector sum of all the electric field for system of n number of charges, what we will do, we will take the vector sum of all the electric field due to individual charge, E2 plus E3 plus up to En. This is the superposition principle. Okay, it's a vector sum. Okay, remember, it's a vector sum. Vector sum is different from algebraic sum, because in algebraic sum what we do, we simply add all the numbers. Okay, suppose you have a 5, 3, 2, 4, then you just add all the numbers. But when we talk about vector sum, then we in that case we also consider its direction. In my previous lecture I already told you how to find vector sum of how to add two vectors or more than vectors, and how you can find the vector sum. Okay, so this is all about its statement. Now now let's try to calculate some neutral points. Okay, some neutral points. So what happened when two charges, okay, so next a small heading or note you can take, it's a neutral points, it's a neutral points. Okay, so what is neutral points? So neutral points, yeah, point at which the electric field of individual charges are cancel each other. So point, neutral point is point at which the electric field of individual charges, electric field of individual charges are cancel each other, are cancel each other. Okay, so these are neutral points. So suppose I take two charges. Okay, so there is a point in between these two charges where electric field cancel each other, means one charge and another charge, they will cancel out each other's electric field. Then at that point net electric field is zero. At that point the net electric field is zero, and that point we call neutral points. That point we call neutral points. Okay, and you can actually calculate the exact neutral points for system of charges. Okay, now let's try to find neutral points for two charge system. Okay. So I'm solving a problem in which I will try to find the neutral point of two charges. Okay, so the problem is, so that you can get the clear idea of neutral points and the application of superposition principle. Okay, got it?
Yes, sir.
Okay, now let's try to solve a problem. The question says two charges, one is plus E and another one is plus 4E, are placed at separation A, at separation A. Okay, small a. At what point on the line, at what point on the line joining, the two charges, net field is zero. Net field is zero. Okay, now let's try to solve this question. So one charge is your plus E, both are positive. So one charge is your plus E and another charge is your plus 4E. And these two charges are separated by a distance A, small a distance. They are separated by a small a distance. Okay, so this distance is your small a. Okay. So there is a neutral point between these plus E and 4E, and that neutral point the point where both the charges, both the field are cancelling each other. So suppose we don't know where is a neutral point, so we can consider any point as a neutral point. Suppose I'm considering this point as a neutral point, this point as a neutral point, and this point is x distance from this positive E. Okay, x, I'm assuming x. So what we have to find, this the value of this x. So what's the remaining distance will be, this will be a minus x, this will be a minus. Is it clear? If you have any doubt, you ask. Okay, if you have any doubt, any problem, then you can ask anytime. So this is a charge I'm considering is A, and I'm considering it as B. Okay, so now the electric field at this neutral point, the definition of neutral point says that the net electric field at this point is 0. So electric field due to point A, due to charge E, which I am writing EA, plus electric field due to this B, charge B, which is plus 4E, these must be 0, because the property of neutral point says that the net electric field must vanishes. Okay, so if I talk about magnitude, means what will be the relation between magnitude. So here EA minus EB equal to 0. This condition must be followed. Okay, because one force is like due to plus E, the direction of one force is like this one, this is EA, and the direction of EB is like this one. So both have opposite direction, both have opposite direction. Okay, so now we can get equation which says that EA is equals to EB. Okay, is it clear to all of you? Is it
Yes,
clear?
sir.
Okay, Maziha, is it clear?
Yes, sir.
Because by using this condition we can easily find the value of x. And what about you, Abdul Rahman? Is it clear to you now? Okay, so now let's try to solve. It's in me chat. Oh yeah, okay. So now let's try to solve this problem. EA is equals to EB. So we get the equation which says that EA is equals to EB. So now we can solve the problem by using this equation which says that EA is equals to EB. Okay, let's solve this problem. So what is the value of EA? EA is the electric field due to charge A, the charge on A, which is plus E. So what is the value? Value is 1 over 4 pi epsilon naught E over x square. Okay, this is the electric field due to EA. And what about EB? What about EB? Minashi, what about EB?
1 by 4 epsilon naught plus 4e by h square.
No. That's mistake you have done. 1 over 4 pi epsilon naught. That's why I asked question. 4e divided by. Let's again see the diagram.
A minus x square.
Yeah, exactly. A minus x, because the neutral point, the distance from plus 4e to a neutral point is a minus x. So you will consider this distance, which is a minus x. So that is a minus x whole square. Okay, a minus x whole square. Now you can easily find out the value of x, and the value of x will give you the neutral point. Okay, so you can solve this problem. Yeah, this 1 over epsilon naught, this 1 over epsilon naught get cancel out. This small e, this is small e gets cancel out. What remains? It remains. It's 1 over x square. 1 over x square is equal to 4 divided by a minus x the whole square. From here you can get 4x square is equals to a minus x whole square. If you take square root both side, so you can obtain the value of you will get the value twice of x is equals to a minus x. Okay, so from here you will get the value thrice of x is equals to a, and from here you can calculate the value of x is equals to a by 3. This is the value of x. So the neutral point lies close to this charge, which is plus e, and the value of this point is a by 3. And what about this distance? Anyone tell me what will be this distance? A minus a by 3 is okay. How much this distance? Saifullah, tell me. If x is equals to a by 3, then what remains? Huh? Minashi, what will be the next distance? If x is equals to a, exactly, that is 2a by 3. 2a by 3. So the neutral point lies a by 3 distance from plus e charge and 2a by 3 distance from plus 4e charge. Okay, so in this way you can solve this problem. Okay, now next question, give me another question. Have you taken the note, all of you, or should I go to the next problem? Okay, okay, so I am moving to the next problem. So next problem is, okay, next problem I am considering both equal charge. Suppose this is your charge 2e and another charge which is same magnitude, same amount of charge, that is again 2e, and these two charges are separated by a distance small a. Now try find neutral point, okay, so try to find it where neutral point will exist. You can send me the answer in chat box. Abdur Rahman, if you are not answering, so please mute your mic. Okay, someone send me answer. Yeah, Minashi got the correct answer. Any other student? Abdul Rahman, are you solving this problem? Yeah, some another. Yes, doing. Okay. I'm giving you 2 more minutes. So give me the answer within 2 minutes. Just follow the same procedure as I discussed in my previous problem. Just follow the same procedure. You will get the answer. And that answer actually is interesting. That's why I have given this problem to you. Two more minutes, then after that I will discuss. And what about Mohammad Shaifullah? Are you solving this problem? Are you doing it, or you're facing some trouble?
Yeah, I just joined, so I don't know how to do this.
Okay. I will again summarize this problem, revise this problem. Okay, yeah, Abdul Rahman, correct answer. And what about Maziha? Are you solving it? Okay, yes or no? Yeah, okay. So I'm going to solve this problem. The problem is interesting because the important thing in this problem is that both have equal charges. So if equal charges, if you are dealing with equal charges, then the result is very usual. Okay, so first I'm going to solve this problem. Again, in this problem, these are two charges. One is plus 2e. Both have positive natures, plus 2e plus 2e. So they will apply equal and opposite force. That's the important point. So suppose I'm considering neutral point somewhere here, and again I'm considering it is separated x distance from 2e charge, and again this is a minus x from this 2e charge. Okay, so again the net electric field at superposition principle says that at neutral point the net electric field must be 0. If I am taking a and this particle as b, then vector ea plus vector eb is equals to 0, and both field are opposite, so you can write ea minus eb equal to 0, and from here you can write ea equal to eb. Okay, not vector. Okay, ea equal to eb. In this case you can write the value of ea. The field is in this direction. Due to ea, electric field is in right hand side direction, and due to b, the electric field in left hand side direction. So write the value of ea, which is 1 over 4 pi epsilon naught 2e divided by x square, and here again 1 over 4 pi epsilon naught again 2e divided by again your a minus x whole square. And here 1 over 4 pi epsilon, 1 over 4 pi epsilon cancel out, small e cancel out. So and 2 and 2 is also cancelled. So what remains? Remains 1 over x square is equals to 1 over a minus x ka whole square, and that will give you a minus x whole square is equals to x square. And if you take square root both side, then you can have this a minus x is equals to x, and from here you can have twice x is equals to a, and here x is equals to a by 2. X is equals to a by 2. This is our result. So from plus 2e charge, this x is equals to a by 2, and this again distance is again your a by 2. So from here we conclude that if two charges have same magnitude, same value, they are equal and separated with a equal separation, then in that case neutral point exists at the center. Okay, at the center. Okay, so in this case you can actually directly get the answer. This must be a by 2 if two same charges, okay, same amount of charges, 2e 2e or 4e or 4e or 80 or 80, and they are separated by a, 2a, 3a, some equal separation, then in that case you can get the neutral point at the center, just in between the charges. In between the charges, here actually there are two charges, so the separation, any separation, just take it half. The neutral point exists at the center, means half distance from one charge and another half distance from another charge. If the magnitude of charge is different, means one is 2e, one is e, one is 2e, one is 4e, in that case neutral point will get shift. But if the magnitude of both the charge is equal, then in that case, if you are considering two charge system, then it will lie at the center or just between the separation of these two charges. Is it clear? Okay, so take a note, write note says that if all the charges, if all the charges are equal and separated with equal separation, then neutral point at center. Then neutral point at center. Okay, this is a very small note. Or you can write this statement in another form, like electric field at the center of symmetrical system is 0. You know what are symmetrical system? Systems which have some kind of symmetries. Okay, so you can write one more note, that electric field at the center of symmetrical system is 0. At the center of symmetrical system is 0. Okay, symmetrical system is 0. So this one point and this is another point, two node point. The charges are equal and separated with equal separation, the neutral point at center, and this electric field at the center of symmetrical system is 0. Okay, net electric field. So for example, symmetrical systems such as, for example, first write down these 2 points. Write down these 2 points. Then I will give you some examples of neutral points. Neutral point for a line, neutral point for a triangle, neutral point for a square. Okay. Okay, I am moving to the next point. Yeah. So suppose if I consider a line, okay, if I consider a line, then in that case, here this is charge Q, and here it is charge Q, and these are separated by equal separation, means A and A. Then neutral point will lie this point. This is your neutral point. Okay. Example. Another example is triangle. If I take a equilateral triangle, means it has some kind of symmetry. If I am considering a equilateral triangle, then in that case, okay, there is, yeah. If I am considering a equilateral triangle, yeah. So the neutral point and three equal charges are separated by equal distance, means plus Q here, again plus Q here, and again plus Q here, and these are distance like A. They are separated by distance A, and these are separated by distance A. Okay, so in that case, the electric field must vanish at the center, and the neutral point will exist somewhere here, and at this point the electric field vanishes. Okay, at center the electric field vanishes. This is your neutral point. Here electric field vanishes, means the E is equals to 0 at this point. E is equals to 0 at this point. Here the electric field is 0. Okay, is it clear? Now next example is if I consider a square, then in that case, yeah, if I consider a square, so the neutral point will exist at the center of this square. Okay, yeah. If I put four charge, a charge here, Q1, Q2, Q3, Q4, and these four charges are separated by equal distance A. Here is A, here is A, and here is A. Then in this case, the neutral point will exist at the center of this square somewhere here, and here the electric field will be 0. This will give you the neutral point. Okay, and next symmetrical body such as pentagon. So in this case, again, okay, no shape. Okay. So if the system is a pentagon, more number of lines, okay, then in this case the neutral point will exist somewhere here at the center of this system, 0. Okay, and if there are n number of charges, suppose a charge here, in this case Q1, Q2, and Q1, Q2, it's Q actually, these are not Q1, Q2, these are equal. So instead of writing Q1, Q2, I must have to write this Q, 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 and again here Q, not Q1, Q2, Q, Q, and Q. So what about if we infinite charges? Okay, if I consider one more charge, then it will be hexagon, 6 charges for 2 for line, 3 for triangle, 4 for square, 5 for pentagon, 6 for hexagon. If I consider n number of charges, then they will form a ring. And in that case, if I put n number of charge, then they will form a ring. And in that case, here, so I charge here, 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 n number of charges, then in that case the center of the neutral point exists at the center of this ring. Somewhere here neutral point exists, and in this point the electric field is 0. Okay, this is for infinite charge. This is for infinite charge. It's be a ring. Okay, now write all the points: line, triangle, square. Okay, and the last one is your ring. So this is all about neutral points and electric field for symmetrical system. These all are symmetrical system. Okay, these are all symmetrical system. There are symmetries. There are symmetries in these shapes. Is it clear? Now take a note. Take your notes, and after this I will solve one more problem related to this system of charges. Up to now I only consider two charges. Okay, but now I will solve a little bit more complicated problem, not so much complicated, but in the next problem which I am going to solve is the system of four charges. The system of four charges, so that you can get the idea how to deal with system of charges. Okay, so I'm moving to the next problem. All of you, have you taken the note? If you're not, then tell me. I will again show my slides. Next problem is yeah, question. In this problem I am considering a system of four charges. So this is our square. Okay, yeah, and it has four charges. The one charge is here, it's a plus q. Another charge is somewhere here, it has value plus 2q. Another charge is here that has value minus q, and another charge is somewhere here that has value minus 2q. Okay, so this is a symmetrical body, yes or no? Yes, it is a symmetrical body, but electric field will lie at the center or not? Mohammad Saifullah?
No, sir.
No. Why?
Because it's not uniform. Charges are not uniform.
Yeah, that's because charges are not uniform, not equal. If all of the charges are plus 4q plus q plus q plus q, then in that case you will get. But in this case you have to find it manually. So what is the electric field? Suppose I am interested to find electric field at the center. If it is not 0, then we will try to find it. What will be the electric field? It is 0 or not, we will find it. If it is 0, then it's very good. If it's not 0, then it has some value, and what is the value? We will find it. Okay, so what will be the field? What is the electric field at center due to this distribution of charges? Okay, so if I give a number, this is your A and this is your B, and here is C and here is D. Okay, so for solving this I am just drawing the diagonals so that we can get the idea about electric field. and here one more diagonal. Okay, because we are finding electric field at the center. Yeah. Okay, so here you can see the electric field due to this charge plus q, it will lie somewhere here. Okay, is it clear? Because the electric field due to positive charge is outward direction, so electric field due to plus q is ea, and due to minus q, electric field due to minus q, it will lie somewhere here, ed. Okay, and due to this minus 2q or c, the electric field is towards minus 2q, because the direction, as I told you in my previous lecture, that due to negative charge the direction is inward direction, is towards source, towards charge. So again the direction is like, the field is like ec here, and due to this 2b, what will be the direction? This 2b, it's outward direction, so it will same as eb. So here you can see that uh, there are 4 electric field, and in which 2 are in same direction. EB and ED are parallel, EA and EC are parallel, but if you talk about this EB, ED and EA, EC, there is a 90° or pi/2 angle. Okay, now we will try to solve this problem, and here is your origin. Here is your origin. Now try to solve this problem. Okay, so so let's try to solve this problem. So first, if I am considering O as an origin, and if I am finding the electric field at this O, then I must know the value of OA, OB, OC, or OD. They are all equal. They are all equal. So if I find OA, then it means this is also equal to OB, OC, OD. Okay. So means OA or AO, that is equal to AC. This AO is AC by 2. AC by 2. Half of the diagonal. Half of the diagonal. AC by 2. And what is the value of this AC? If this distance is A, all are separated with a distance A. Okay, all are separated with a distance A. So what will be the value of this AC? We will use Pythagoras. Pythagoras says that this AC will be the square root of DC square plus AD square. Is it clear? So that is, this AC is nothing but 1/2 square root of AD square plus DC square, both are A square, so you can write 1/2 square root of A square plus A square, and that is your, you can take A outside, A root 2 by 2, and that is your AO is equal to A by root 2, which is equal to BO, which is equal to CO, and that is also equal to DO. Okay, is it clear? First I calculate the value of this distance from every charge to center where we are interested to find the electric field. Okay, now this AO will work for us to find the electric field. Okay, now let's try to find electric field due to these charges. So first, what will be the electric field due to this charge Q plus Q? So means electric field due to charge A. Electric field due to charge A means EA. So EA is equal to K. K means 1/4πε0. K into Q divided by R square. And what is the value of R? What is the value of R? Minashi, what is the value of R here? R square?
A.
Not A.
A
Again,
by root.
see, A by root 2. Very good. So A by root 2 is the is the value, means a divided by root 2 whole square. This is your EA. This is your EA, and what its value? It's if you put square, then that will give you 2kq divided by a square. Okay, this is your EA. Now next field is EB. EB is again here, the only change is 2q, and the value of r square is again same, a by under root the whole square, and the value of EB here I'm only calculating the magnitude. Okay, so here the value of EB is 2qk divided by a square. Okay, next EA, EB, EC. The value of EC is again C here is 2 minus 2q charge. Okay, I will consider only magnitude form because the minus term will give you the direction. And EC, you can find the value, it's k, it's 2q divided by a by root 2 the whole square, and that will give you 4kq by a square. Now what about ED? ED has only q charge, it don't have value 2, so it will give you kq divided by a by under root the whole square, and that will give you 2kq by a square. Okay, now we find all the electric field as individual charges. Okay, up to now, is there any problem, any doubt? Because after that we have to apply the superposition principle, because we have to find the net electric field at the center, and this is the electric field due to individual charges. Okay, somebody asked me a question, sir, how did we get 2q? 2q actually is given, 2q charge is a given, na? So I think is it your question? This 2q charge is given, so in that case 2q I am considering 2q. If what is the formula of electric field? Electric field, the formula of electric field is E is equals to 1 upon 4 pi epsilon naught q by r square. Q behave as a source, means point charge, means it may be 2q, it may be 3q, it may be 4q. If it is 2q, then the formula will be 1 upon 4 pi epsilon naught 2q by r square, and if it is 4q, then 4q by r square. Q is a general form, capital Q is a general form in that formula, but it depends on what is the amount of charge you are taking, and then that will behave as a source of that electric field. Okay, so if it is 2q, then you will put 2q. If it is 4q, then you will put 4q. Okay, is it clear or you have doubt? Clear? Okay. So these are 4 electric field. Now I will try to find the net electric field. Okay, here you can see in this diagram 2 electric field are in same direction, means EA and EC are in same direction, EA and EC are same direction, and EB and ED are same direction. So we will individually find EA, EC and EB, ED, and after that we will apply again the addition of vector. Okay, so first solve this EA and EC because it's in same direction. So the net electric field due to this EA and EC, that is like E A C vector, is a sum of vector EA plus EC, and here I will apply the vector addition rule. What is the vector addition rule? If two vectors are parallel, so what is the formula? As I told you in my previous class, that if you add two vectors, then the formula is magnitude of EA ka square plus EC plus EC square, EA square plus EC square. What is the formula? If two vectors, then A square plus B square plus 2AB cos theta. That's the formula, na? Plus 2EA, and here EA and EB, EC, so that's why I am writing cos theta. Okay. So what is the value of cos theta here? Theta is, what is the theta here? Theta is 0. Theta is 0. So in this case, you will get theta is 0. So you will get under root EA square plus EC square. I'm not writing directly. I can also write indirect way that this is nothing but EA plus EC ka whole square. This will be EA and EC ka whole square, and in this case the square root will get vanish. So if two vectors are parallel, then in that case its sum is just simple sum. Vector AC is equal to EA plus EC. Because angle is theta is 0, so in that case it will be whole square, then you can directly add this EA plus EC, and that will give you the value of EA is 2k cube by a square and EC is 4k cube by a square. The value is 6k cube by e square. Now we solve another part of this problem. We just add these two vectors, means EA, AC, EAC. We find it. Now the next task is to find this another these two values. We have to again add these two values, not algebraically. Vector addition, we have to do vector addition. In this case, what is the field? It's EB and ED. Both are vector. Okay, both are vector, but they are parallel vector. As I told you, if the vectors are, if angle is 0, then it's the vector sum is simple sum. Okay, but it's not apply, you cannot apply this in all the cases. If angle is 0, in that case only you can apply this. So next, the vector BD is the sum of vector EB plus vector ED, and that is nothing but EB plus ED. And we already find the magnitude of EB and ED. What is the value of EB? EB has value 4k cube by a square, ED has a value 2k cube by e square. So if you add these two value, 4 plus 4k cube by a square plus 2k cube by a square. In this case, you will get the value 4k cube by a square. Okay, now we find we apply superposition principle here and here. Okay, now we have to find the net electric field. We calculated two electric field. One is in this direction. This was our problem. We have a square. Okay, we have a square, something like this structure we have in our problem. This was our problem. This is like a square, all the charges. Okay, this is our center. So what we calculated up to now, we calculated the field due to these two charges. One more question, I think. Sir, where does root go? Okay, so again here, let me write it clearly that yeah, cos theta, here theta is 0, here theta is 0. So when theta is 0, so cos theta means it will give you value cos 1, cos 0 is 1. So in this case it will like a square EA square plus EC square plus 2EA EC. Okay, and that will give you, this will be your complete square. Okay, I'm writing here. This will give you under root EA plus EC whole square. That's why this is square root and square root cancel each other. Is it clear now? Okay, is it clear? Or Muhammad Abdul Rahman, is it clear? Means if angle is 0, then it will be a whole square. That's why square root vanishes. Give me answer, yes or no, so that I can go to my problem. Yeah, okay. So next we have to apply, we have to solve this two direction problems. Yeah, okay. So one we solved. Yeah, this is your EAC EBD vector. Okay, let me draw diagram more clear way so that you can get it. Yeah, okay. Yeah, this is our problem. We have a square and we have two field. One is, this is our center, one in this direction. This field is E of BD vector, and there is another field which is like here. Okay, and this field is nothing but it's a vector E of AC, and both are, the angle between them is pi by 2. Now we will find the net field at the center. The net electric field at the center. Okay, the net electric field is vector E is equal to EAC vector plus EBD vector. Okay, let me very clear. EBD and EAC both have equal magnitude, but they are in different direction. The angle between EAC and EBD is pi by 2, and we have to deal it same as addition of two vector. Okay, so in this case again, if I apply the formula, the addition of two vector, that says that magnitude of EAC the whole square plus magnitude of EBD the whole square plus 2EAC 2EAC EBD and cos theta. And what is the angle here? What is the angle here? Saifullah, what is the angle here?
90.
90 exactly. 90. So this will what happened? What is the value of n cos pi by 2? Minashi?
Sir,
What is the value of cos pi by 2?
1.
The angle is, what is the value of cos pi by 2? Because here the angle is pi by 2, na? 90.
1.
1.
It's
Cos 0 is 1. Exactly. Cos 0 is 1 and cos pi by 2 is 0. So in this case, this theta is pi by 2, and you know cos pi by 2 is 0. So in this case, this term will get vanish. This term get vanish because cos pi by 2 is 0. So the remaining term is like under root EAC square plus EBD square. Let me write in detail, otherwise some student will face problem. EAC EBD, and that is cos pi by 2, and this term gets 0 because cos pi by 2 is 0. Now finally the net electric field at that center is nothing but it's the magnitude. The net electric field is the under root EAC square plus EBD square, and as we know EAC is equal to EBD, so you can write it as under root twice of EAC. And what is the value of EAC? It's a 6 Ka, or you can directly write all this value, otherwise you will get confused. EAC EBD, right? EAC, the value of EAC the whole square. Okay, let me write here. EAC, what we calculated, it's 6 KQ by A square and what we calculated EBD, it's again 6KQ by A square. Both are equal. So from here we can write this is equal to 2EAC the whole square. We can take common out EAC. We can take out this EAC, square root of 2, and the net electric field is E net electric field is 6KQ by A square root of 2. This is our net electric field. And what will be the direction? As I told you, if two vectors have equal magnitude, they are equal, then the net of these two vector will bisect means it will 45 degree from here. The angle is 45 degree. Okay, if these two vectors are equal and the angle between is pi by 2, then the net field will pass the direction of this, the net field will bisect the angle between these two vectors. Means if the angle between EAC, here the angle between EAC and EBD is pi by 2, and both are equal. If EAC and EBD are equal, so the net electric field will bisect the angle between this EAC and EBD, and it will pass somewhere here, 45 degree from EAC or 45 degree from EBD. So this is your problem. It's a big problem. Okay, try to solve this problem in your home again, and if you have any trouble, then I will repeat in my next lecture, but write it down. Okay, take your note. Are you writing? Are you taking note? Take a note. I will slide down. If you finish this slide, then say me that slide down. Take a proper note of this problem because it's an important problem. This is the if you able to understand this problem, then you can deal with system of charges and you can easily apply the superposition principle. Okay, so today's lecture was totally based on superposition principle, in which we solved I think 2-3 problems. Okay, we studied what is neutral point, what are neutral points for different kind of bodies. Okay, now take a note of this problem. It's very simple. Try to solve it. Okay, try to solve it. And what about you, Muhammad Shaifullah? Have you prepared the Viva? As I told in my previous class that I will take a small Viva on Monday. Abdul Rahman and Shaifullah, I think both of you are late. That's why you miss that Viva session. Okay, first take a note of this problem. Then I will discuss some more thing. Okay. Are you guys done with your note? Yes or no? Have you taken the notes of this problem?
Yes, sir.
So I'm going to the next topic. Today I will give you a very small introduction of that topic. In my next class, I will consider it in brief. So today, the next topic which I'm going to discuss is your electric dipole. Electric dipole. Okay, what is an electric dipole? I will just introduce today. I will just introduce the major portion. I will do in my next class. So before going to dipole, first I will discuss what is a monopole. What is a monopole? What is a monopole? Monopole. 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 If I consider single charge, if I put a single charge here plus q charge here, then in that case it will behave as a monopole. But it has only one pole, means here the field will go like this one here, this one here, this one here, and this one here in every direction, and it will behave as a single pole. Okay, it will behave as a single pole, means the field is going outward from this plus q charge, but there is no point where the field will go inside. Okay, so monopole exists in electrostats. But what about magnetic field? Is monopole exist in magnetic field? Anyone? Saifullah, what do you think? Monopole exists in magnetic field. Monopole means it has only one source of field. There is no another point where the field line going inside of that point. Okay. So what do you think? Monopole exists in magnetic field? Saifullah, are you listening me?
Yes, sir.
What do you think? Monopole exists in magnetic field?
Yes.
Okay. So how I don't think so monopole exists in, because whenever we talk about magnetic field, suppose if I consider a bar magnet, then a bar magnet has two poles. One your south and another is north. No, north-south pole. If I break this again magnet, then another pole will get south and this will get north. So in magnets, monopole doesn't exist. Monopole only exists in electrostatics. I will discuss it in brief in your magnetic field chapter. Means the monopole means it has only one charge. If I put another charge, suppose another charge minus q, then in that case what happened, this field line will go inside this q. This field line will go inside this q. And in this case, today I'm just introducing. Then in that case, it will be a dipole. Then in that case, it will be a dipole. In that case, it will be a dipole. Okay. So monopole means only one charge, and dipole means when if I consider two equal and opposite charge, then they will behave as a electric dipole. Okay, that's a very important topic which I will discuss in my next class. The topic is electric dipole. Very important topic in your electrostatic chapter. Electric dipole. What is electric dipole? This I will discuss in my next class. Okay, today I am stopping here. Here I am closing this class. If you have any doubt, any query, then please ask. If you don't have any query, then I'm closing this class at this moment. And next topic is electric dipole, which I will discuss in my next class. Okay. Okay.
Yes, sir.
Okay. So see you guys.
Thank you, sir.
You're welcome.
Aren't you taking Viva for us?
Yeah, I actually took Viva for 2 students, but I think you were late. So if you're interested, then I can ask some questions to you, so that I will get the idea that you are properly taking revision of your previous classes or not. Should I ask few questions to you?
Yes, okay, sir.
Yeah, sure. So the topic of Viva, I think is electric field and electrical forces. Okay, electric field and electric force. So the first question is, what is dielectric constant? What is dielectric constant? Hello, are you listening me?
Yes, I'm listening.
So my question is, what is dielectric constant?
Is it K?
Is it K? But K means how you define this dielectric constant? How you define this dielectric constant? Or relative permittivity? Both are same thing. It's the ratio of, as I told you,
Equals to 1/4 pi epsilon naught.
no, means K is a ratio of absolute permittivity and K is a ratio of absolute permittivity and permittivity of free space. In this way, you define dielectric constant K. Okay. Take a look of your notes, or I defined this absolute permittivity as K epsilon naught, which is equal to epsilon R epsilon naught. Okay. So this is your dielectric constant. Okay. Next question is if I consider a source charge plus Q, then what will be the electric field at the distance R from this point charge capital Q? If I, in a short way, I can ask that what will be the electric field due to a point charge? What is the expression of electric field due to a point charge?
KQ equals to by R square.
That's correct. Electric field due to point charge, that is K capital Q divided by R square, if I'm considering that point charge as capital Q. Here this K is different from this K. Okay, this K is electrostatic force constant, and this small k is your dielectric constant, this K. Okay, these are actually difference between these two K. One more question. what is the relation of force? What is the relation of force in terms of absolute permittivity or dielectric constant? What is the relation of force? Or you can say Coulomb's law in a medium.
E equals to K Q1 Q2 by R square.
Yeah, here you have to give answer in terms of 1/4 pi, something like that, because in terms of K I will not get the exact answer. So the relation, suppose, yeah, you're not get hello,
Yes sir, yes sir.
have you get my question?
Can you repeat
Suppose
again?
Okay, suppose I put a charge q1 here and another charge q2 here, and they are separated by a distance small r, and this system is inside a medium of dielectric constant k. It's a medium of dielectric constant k. Then what will be the expression of force in this condition? What will be the expression of force? So it will be, the only difference will come in in permittivity. Now you get my question.
Yes sir, I get your question.
Okay. So I'm giving the answer. Okay. After that, take a proper revision. The value of force, the general value of force, not in free space, in a medium, we consider it 1/4 pi epsilon q1 q2 by r square, and epsilon is nothing but it's a 1/4 pi k epsilon naught q1 q2 by r square. And in vacuum or free space or air, k is equals to 1. That's why we consider f is equals to 1/4 pi epsilon naught q1 q2 by r square. But general form is, for any medium, the Coulomb's law can be represented in this form. Okay, is it clear?
Yes sir.
Okay, so okay, it's enough for Viva. Okay, so we will meet in our next class. Okay, Saifullah.
Yes sir.
Okay, bye bye.
Thank you sir.
And take a revision of this class too. Okay.
Yes sir.
Okay.
Thank you sir.
Okay, welcome.